Okay, so welcome everyone. Good afternoon. Thank you very much for joining us on this virtual meetup. We are going to be talking about how to use smart contracts and QLDB to bridge data silos within an enterprise. So hope everyone is keeping safe. We've got an exciting webinar in store for you today. And then of course, I promise when we finally get back to our physical meetup space, definitely lots of appetizers and drinks. And for today, we'll just manage virtually. So before we start, I wanted to get our panelists to say a quick hi to all of you. We got Lana Kalashnik from AWS. She's the Global Partner Technology Lead.
Hey everyone, this is Lana here. Great to be in this chat, and hopefully everything is going to go smoothly with our virtual format.
Yeah, and then I've got Duncan Johnston-Watt. He's the CEO for BTP. He's going to be showcasing the Sexton platform that's actually integrated Daml with QLDB.
Yes, hi everybody. Delighted to be on the call as well, and looking forward to the next hour or so.
Perfect. And then I've got Levante Barzi Levy. He's a client engineer at digitalasset. He's going to be taking you through a simple trade finance application and discuss how it's probably maybe more practical to deploy it on something like QLDB. Levy?
Yep. Hi, everybody. Looking forward to this. And I think during my section, we'll jump into a little bit of the code as well as take you through the out-of-the-box UI.
Perfect. Yeah, and this is Manish. I look after channels and solutions at digitalasset. So before we start, I wanted to quickly introduce digitalasset a little bit. So we created Daml, which is the smart contracting language. It's in use at several corporations across the world now, across multiple industries. One of the first ones is going to go live this year. The Australian Securities Exchange. They are deploying their entire post-trade equities settlement platform onto Daml. Daml is now open source, of course. And the interesting thing is that Daml runs on multiple ledgers, not only blockchain platforms, but also traditional databases. And very relevant for us today, it runs on QLDB as well, which is pretty exciting. And obviously, I wanted to also mention Project Daml, which is our cloud environment meant for startups and enterprises alike to get to market faster and avoid all of the complexity of managing the infrastructure themselves. So what is Daml? Apart from Daml running on multiple ledgers, and of course we'll be talking about QLDB today. The two important things, exciting things that stand out is, first of all, Daml is fully portable. So once you develop your application, you can deploy it on any ledger that Daml supports. It's important because now, when a project starts, you don't have to decide what's your deployment target. You can develop your application, run it by the stakeholders, do some engagement, run some use cases, and then finalize your requirements. And then when you decide to go to production, you can choose which platform you want to deploy it on. So it saves a lot of overhead in the beginning of the project. Something that's coming up pretty quickly, very excitingly, Daml applications can interoperate across blockchain platforms. So you can have your network running on Fabric, for example, and on the other side you've got your applications running on QLDB, and now Daml allows you to transact across the two deployments. So that's really exciting. It's coming up soon. So the issue that we're going to be dealing with, and that's why the blockchain came into play, reducing silos between enterprises. Any business process, of course, has multiple enterprises that come together to make it happen. Your health claims, for example, it runs from your hospitals to your insurance providers and many other intermediaries in the middle. Each of them have their own data silos, and the result is that each of them have to obviously run reconciliations between themselves, and it leads to obviously costly process breaks, a lot of latency in information that is visible to stakeholders, and a lot of customer experience issues. So that's what we are trying to do, bringing everyone on a common data platform. So everybody still has their privacy, but they all have access to a single golden source of truth. And within the enterprise, it's very exciting. And the use cases that we're going to be talking about today, especially with QLDB, pretty exciting because thinking about, when you make a credit card payment, for example, your payments don't appear on your on your online platform immediately. Sometimes they are, sometimes they appear the next day, next morning, sometimes with a lag of a couple of days. That shows us, the problems that enterprises face in having so many different databases and applications that are responsible for executing different parts of a business process. And that's what we are trying to address with Daml, helping you bring all of these applications, integrated so that they access a common golden source of information at any point in time. So you see, the issue that we have now is you've got a business process and it's a virtual pipeline between all of the applications because obviously, they are aligned with their org hierarchy and they are all searching for that single source of truth. And it leads to several operational challenges, not only for compliance, but also for business intelligence, predictive analytics, et cetera, that you might want to run. And this is example, these things are common across any business process. I mentioned claims. You can think about mortgage and lending, thinking about credit applications. You're applying for a credit card, needs to go to compliance, needs to go to your fraud department later on. You're making payments on it, and each of these systems are different from each other, trying to reconcile with each other instead of a common digital asset underlying each of these applications on which actions are being taken. So that's the big difference that you'll see with Daml in the trade finance example that we show you. And obviously we'll show you, how it becomes even more easier when you've got something like QLDB at the bottom of it. And of course, for all of our data scientists out here on the webinar, and also, you're familiar with the data pipeline. You aggregate your information, you reconcile and clean the information, make it consistent. Then you enrich it because you might need to augment the data from other sources. And finally, you get to analyze it. For compliance purposes, for business intelligence purposes, and even for predictive analytics and artificial intelligence. 60%, up to 60% of the time is spent in the first two phases. And that's what we're going to try to solve through Daml and QLDB. So just to set a quick context there. So Lana, I'll hand it over to you now to tell us a little bit about QLDB. And I'll stop sharing so you can share your slides if you need to.
Okay, sounds great. Thank you so much.
Yeah.
Alrighty. Hi, everyone. My name is Lana Kalashnik. I lead technical workflows at Amazon, managed at Amazon Partner Network. So we have a few other folks on the call that are working with our partners, such as Maggie Shu, who is our leader for ISV solutions in blockchain and ledger technologies. So today I wanted to take a few minutes and tell you a little bit more about some of the work we've been doing that is thinking outside of the box and really focusing on the customer of how we approach designing these distributed and decentralized solutions. So as far as cryptographic verification and ledger technologies at AWS, something that I'm very excited to say that we definitely are seeing growth. So over the last couple of years, we've worked with a ton of technology partners, consulting partners, and are building our own solutions under the hood too to support all major blockchain protocols via our own services and our technology partners. We also have built a dedicated marketplace category, which again speaks to the growth and the bubbling up of new ways of doing business on blockchain and ledger. So decentralized versus centralized solutions, which is something we're going to be talking about today a little bit, how Sextant is actually leveraging EKS and other open source technologies to bring about Daml on QLDB and on Sawtooth too. So very cool stuff there. And we'll be focusing on blockchain solutions going forward, which is why here in this talk, we will be really diving into a financial settlement application to demonstrate exactly what is the value proposition of a ledger technology and a smart contract, and how do we bolt it all together under the hood. As we were looking to understand how our customers are using blockchain and ledgers, we realized that there are two separate branches of use cases that we were finding. The first one is where customers really needed verifiable ledgers or data stores. They needed transparency, auditability, but they didn't necessarily trade or share their infrastructure with other companies. So essentially they didn't need decentralization. So some of the use cases that fall under here would be healthcare. So verification and tracking of hospital equipment, which is very relevant right now, as we can see, of how do we actually join all of these disjointed supply chains and audit them for quality or redistribution. Use cases like DMV and public sector. So we've seen a ton of use cases there that falling under this category, where you don't necessarily have multiple mistrusting parties in the network, but you do need to still conduct audits and have a high trust guarantees for your data. Manufacturing processes also fall under here, and some of the use cases in HR and payroll. Clearly tons of applications and financial use cases, but I'll let Duncan and folks from DAs or Daml speak to that. The second use case, the second set of use cases rather, would be falling under transactions that require decentralized trust. So these are your financial institutions that are facilitating peer-to-peer payments, some more complex mortgage processes, so let's say syndicated loans, supply chains, specifically supply chains that are cross-border and transacting with multiple suppliers and distributors where there's not a clear single owner of the network, and streamlining retail operations. So whether this is loyalty and rewards or just shoring up and netting out your inventory across multiple distributors. So because of this, we brought to market two different solutions from our native services perspective. The first one is Amazon Managed Blockchain that really speaks to decentralized trust. But today we're going to be talking about the first use case, which is QLDB. So QLDB is an immutable append-only sequence database that also has properties such as cryptographic verifiability. It is serverless, which makes it highly scalable and easy to use. So we've put quite a lot of thought in the design of how to interact with the ledger itself. So it leverages familiar SQL operators called particle. So essentially, if your employees or your peers are familiar with SQL, they will pick up particle pretty easily. It supports ACID transactions, which is really, really important to not to have false reads or skews on your data. So QLDB supports the highest level of serialization of all transactions, which means that if you're committing something to the ledger, let's say you're transferring funds from account A to account B, the entire transaction will either succeed or fail, which is really important for quality of data. And this is a journal first database, which is something that we'll spend a few minutes on kind of diving into why this is such a unique solution. So when we're looking at traditional databases, the way the architecture typically is built, the log is an afterthought, right? So when was the last time any of us really looked at the log? Typically when things are not going that great. Well, with QLDB, we kind of took this concept upside down and actually built a journal first database that really takes the log itself as the first class citizen. Again, in the past, it was very difficult to directly access the data. And usually if we did use logs for verification and auditing of data, that was a bolt-on house-made solution, which again is expensive to maintain and run long-term. So in Amazon QLDB, the journal is the database. Unfortunately, we won't have enough time to really dive in super deeply in QLDB, but there's a ton of information available on our website and will be available after the webinar to answer any questions. But if you're looking here, we're noticing that when you're writing application data, you're interfacing with QLDB just like you would with any database. So all of the transactions along with metadata and operations are written to the journal. So each one of these blocks here is a block that is also cryptographically linked to the next one. So this is a similar approach as we're using SHA-256 in blockchain applications or blockchain protocols to make sure that older blocks cannot be modified without it being detectable. Another thing that is really cool, as soon as you're writing a journal transaction, so let's say we're creating a new table or inserting a record into a table, it is immediately reflected in the ledger. So here, the top two blocks top two sections in this diagram represent the ledger itself. So as far as the ledger, we have the current view and the history view. So when we're talking about, let's say, a Tesla, so we're adding a new car to an inventory, we'll be able to query that from the cars table, I would say, but also look at the history of all changes to that data through history. Another awesome thing about QLDB that I really like, because we've actually open sourced this, is ION data format. So QLDB is based on documents, so this is not a relational database. So all of the records that we're persisting into QLDB are actually written in ION data format, which is a superset of JSON. Again, JSON is very widely understood, but with ION, what we did is we've added a lot more flexibility and precision in the way numerals are evaluated. So let's say when we're talking about engine sizes, as you see in this demonstration, we can actually show them as decimals, which is not something that you can do in JSON, where you only have a number, right? So you have to do, when you're parsing text or JSON, you kind of have to deduce what data type it is. The same thing for nulls. So you can actually provide a binary and text evaluation of numerals, which is really important. Also, we have dot notation, comments, and new data types such as timestamps, blobs, and etc. So it is much more flexible of a format. It's available on GitHub, open source, so please feel free to use it outside of QLDB even. And also Particle, which is a superset of, actually no, it's not a superset. Particle is a SQL compatible querying language that goes together with QLDB, which allows you to query non-structured data, so documents with a SQL-like syntax. So essentially, it's a super powerful tool for you to be able to query non-relational and relational data with the same set of queries. Makes for much more elegant nested queries, I would say, and kind of gets you out of the habit of creating nasty joins and using QLDB as a relational database, which I want to get this clear and loud. It is not a relational database, and it's not a blockchain. So it's a new journal first type of a database here that we've built. So let's look at how QLDB works. Let's insert a record into a table of cars, which we've created through our particle statement. So we've called this command, right, to insert Tesla S for Tracy Russell, who's the owner of this vehicle, into our journal. So journal here is going to be cryptographically linked to all of the following blocks and persisted into QLDB. So here we're seeing that we have the record itself. So this is going to be an ION document with some metadata. Immediately, this will be shown to us in the current and history views. So another cool thing here, if you worked with blockchain, we know that you can never modify or change data. It's completely append only. So from that perspective, our journal is append only immutable part, but the part in the ledger actually is mutable, which is a much more elegant solution if you don't need decentralization. So let's see what happens when we need to modify an owner of this vehicle. So we updated the owner from Tracy to Nash, and the entire SQL statement or particle statement, all of the data and metadata is persisted into the journal as the next block, and we have linked it via a SHA-256 hash to a previous block. So there's no way to modify it. Actually, we didn't even build the APIs to be able to change or delete anything in the journal itself. So as we're seeing here, immediately the value has been updated in the cars table. And our history for this cars table has been appended with the change of ownership. So as we can see here, we can have a complete history of all of the changes on the transaction along with the view itself. And let's say we want to take a vehicle for this VIN out of our inventory for whichever reason. So here we're deleting cars, we're deleting a record with a VIN 1, 2, 3, 4, 5, 6, 7, 8, 9. Very secure identifier here from table cars. So again, we're seeing here that we're adding another block to the journal itself, which is again cryptographically linked to all of the previous blocks via hash. Just was the call itself and some metadata. Immediately, the cars table has been reflected to take this vehicle out of the inventory, but in the history, we are seeing all of the transactions. So even though this vehicle under this event is no longer shown as being cars in our inventory, we can pull up a full immutable history of transactions and data taken on this item. And another thing, if you're noticing here, which Ion shines, is that when we're looking at a car history, you can see that there is no rows in the table, right? So, which is because this is a document-based database. So, a pretty cool stuff. So the only thing that we reflect in the history is the vehicle has been deleted. So this has been a super fast overview of some of the properties in QLDB. They're going to come in really complementary to Daml as far as the asset persistence, some of the security guarantees. Something that I haven't covered in those slides is how to perform verification of data. So the way you would do that is by generating a digest after an insert. So let's say you've sent 50 cars to a reseller and you wanted to make sure that you have the proof that you've committed all of the records. So you would generate a digest, which essentially is a tip of your Merkle tree. So it's just a one hash strand that you can save locally and then later come back and compare it to the QLDB ledger to prove that everything matches. We know just with this one simple hash comparison, we can attest to the integrity of terabytes worth of data or trade settlements. So pretty cool concepts there will be available via chat and after the call for any follow-up questions. And and I will pass it on. Thank you.
Yeah. Thank you so much, Lana. And yeah, folks, please feel free to post your questions in the Q&A panel, and then I can post them to Lana and the other members of the panel, as appropriate. Actually, Lana, thank you for a great presentation. I think it's really complementary to Daml, and what you outlined also shows us, how the way we look at data is changing. So the way we look at, transactions on a particular car, instead of looking at them in isolation, now we're looking at them as operations on a car that is happening, so that you can maintain the entire history, etc. So that's a fundamental, mindset shift as well. I think that's coming about now. So I'm going to hand it over to Levi. Levi now, he's going to take and show us a trade finance example, a simple reference trade finance application that we wrote up. And he's going to show us, how that works, and how, what does the Daml behind it look like, and why it would be a good candidate for QLDB.
Okay, so I was going to jump right into the application, but I kind of think that this would segue nicely from what Lena was talking about with how QLDB was working. So this is kind of under the hood of the demo I'm about to show you, but hopefully you can see some of the ways that Daml ties in nicely with QLDB. So Daml is a smart contract language that lets you define the data and semantics associated with smart contracts that sit on a ledger of some sort. In this case, QLDB. And what most of the time that you're writing Daml, you're describing these things called templates, which kind of relate to tables within QLDB. The layer that Daml adds on top of sort of the assurances and the integrity benefits of QLDB is that you're defining sort of row level permissions. I say row even though Lena just says that there aren't really rows, it's mostly objects, and Daml reflects that as well. but most of the time, each of these templates you could think of as a table, and the permissions, including the read, write, and disclosure permissions, are all spelled out 100% within Daml. So for example, I have a template here called contractual relationship, which ties together manufacturers and their subcontractors. And we see that only the contractors are able to see the details within that party. So you'll have different contractual relationships between different sets of parties, and only those stakeholders which are members in those contracts will be able to see it. And this is by construction. Anytime there's a stakeholder on a Daml contract, they will be able to see that contract basically ported to them. So in this way, QLDB provides all of the things that you want from a very good persistence layer, namely integrity, immutability, ACID, and all of those things. And Daml provides a way to express your business logic on top of that in hopefully a human readable way, where you don't spend a whole lot of time dealing with cryptography, hashing, serialization, or any of that stuff that the persistence layer is very good at. So for example, this fulfillment request has a requester, a subcontractor. It has a number of details. Now this order details is a higher level data type that we've created that maps directly into a complex QLDB type. It's between different contractors, and it's referring to an existing contractual relationship. So these templates tie together. They define workflows. They define how disclosure works, and they define the rights of various participants in a multi-party network of what they can do at what time. So the entire process that I'm about to show you has been expressed within Daml, complete with authorizations, with rights, with disclosure, in about 230 lines of Daml. And that, without any modification, without having to write a single line of SQL code or ledger-related code, will express that business workflow. And as Duncan will show next, it's going to work directly on QLDB without you having to worry about the integration between QLDB and the Daml runtime. So hopefully that's good context. And so I'll jump right into the demo to see what exactly this 230 lines of Daml do. Okay. So after I write my Daml, actually, just a second, I had the item up. Oh, I guess I'll start again. I'm going to connect the navigator to my Daml model right now. So pretty much out of the box, after you write your Daml model, the SDK creates a UI for you that allows you to allows for some customization, as you'll see, so you can change the colors and things like that. But it lets you at a development level play around with your Daml workflow. So the workflow that we have prepared here is between a manufacturer, multiple subcontractors, an external auditor, and a bank. The idea is that a manufacturer can subcontract some of the items out. It can get approved by an external auditor, and it can get financing from a bank. It's a multi-party application, meaning that which in this case means that only people who are stakeholders to a contract are able to see the details that they want. So let's go ahead and log in as a manufacturer. And this is the UI that sort of comes right out of the box. These are the different actions that we can take. These are the different types of contracts that are represented as Daml contracts. And as the manufacturer, what I'm going to do is I'll select my role contract where I can either invite other participants to as subcontractors, or I can create a fulfillment request. So here in this case, I'm going to go ahead and invite a subcontractor to participate in a deal. So I created that contract now, or I exercise a choice on my role contract to create an onboarding invitation. I can see that invitation, and because the subcontractor is a stakeholder within that invitation, they're able to see the invitation. So here we go. There is an onboarding invitation. I can go ahead and click it and say, okay, I accept the invitation. And I can see the details of who's involved here. It's just the manufacturer and myself right now as the subcontractor one. Further, now I have a contractual relationship between the manufacturer and the subcontractor. So what I'm going to do now is invite the next two subcontractors. Okay, so I invited subcontractor 2. I'm going to go ahead and log in as subcontractor 2. There is an onboarding invitation from the previous guy, and I'm going to accept that. And now we see that this contractual relationship is getting bigger and bigger. Go ahead and check that out. I'm going to invite the next person. And by the way, the reason I'm able to invite other participants into this relationship is because they've been explicitly spelled out on the Daml contract. Okay, so, and nobody else can do that, by the way. So if I logged in as a bank or something like that, in fact, I'll go ahead and do that. So I'll log in right now, subcontractor 4. And in fact, I don't see those contracts that have been passed around between those 4 participants so far. So let me go ahead and log in as subcontractor 3. So now there's a contractual, oh, actually I have an onboarding invitation from 2. I'm going to go ahead and accept that. So now at the end of this, there is a contractual relationship between those 4 participants. Go ahead and click on that, between the manufacturer and the 3 subcontractors. And you can imagine what's going on at the QLDB level here. Basically, we're appending transactions to this log and changing this contractual relationship from one version to the next version to the third version. And what Daml allows us to do is it controls the rights, obligations, and the disclosure of that contract as participants are interacting with the ledger. Okay, so after this relationship is done, I'm going to get this approved by an external auditor. So I'll log back in as the manufacturer, and I am going to request on the contractual relationship a certification for this. So I'm going to say, please external auditor, audit my relationship. So there is a certification request that only myself as the manufacturer have entitled to, as well as the external auditor. So there is the certification request, and I'm going to go ahead and certify it. A very important point here that I kind of forgot to mention, but obviously in a real distributed settings, I wouldn't be able to log out and log in back like this. All of this would be assured using some sort of a public-private authentication scheme that would be enforced at the level of the persistence layer. So the logins and so forth would be ensured by QLDB. Here, this is sort of a developer version and lets me do these types of demos, so I can have access to everything very quickly. But this is just for developers.
Yeah. So Levi, a couple of questions at this point that came out. Number one, of course, I wanted to comment that the fact that Daml contracts are private by default to the stakeholders who are defined on the contract automatically ensures privacy, but also automatically gives you an authorization layer. So none of the parties who are not supposed to be taking any actions, the Daml runtime is not going to allow them to take an action. Like, Levi said, a bank, for example, will never be able to onboard a supplier or create a record in QLDB which allows them to onboard a supplier to a particular chain, because they are not defined in Daml in the contract to have that choice. Yeah. The second, Levi, a quick question that came for you is, how instant are these Daml transactions on the ledger? Can there be race conditions?
So in the case of QLDB, the sort of the race conditions or the or something like double spend protection is enforced at the level of the persistence layer. However, performance in general depends pretty heavily on the persistence layer of your choice. In the case of QLDB, I'll let Lana talk about it, I think, in a little bit more depth, but that's pretty much what you'd expect from an enterprise grade current generation database. Yeah. Having said that, I think the question might be more technical. Like, I have this contract flying around, and what if multiple manufacturers or subcontractors are accepting? It's possible that the contract ID will continue to increment, and you will by accident approve a contract that has already changed shape, right? In that case, the double spend protection kicks in, and you'll get basically a friendly error message saying that you're trying to exercise on a choice, a mutating choice on a contract that has already been mutated. However, since you're likely to be a stakeholder on that new mutated contract, you will be notified of the archival of the previous contract and the creation of the new contract.
Yeah, so that's the UTXO model. Basically, you take an action on a contract which is archived, and the next transaction that comes on it to the runtime, that's going to be rejected, and you're going to be asked to work on the active contract at that point. Lena, I think there's a question for you on performance. I think it came up in the Daml thing. Do you want to comment on QLDB's performance quickly? I think there should not be any issues, but if you want to clarify that.
So performance expectations on your infinite scale. I think it would be good to get a little bit more details on exactly what we're talking about performance. So we're talking about reads or writes or things of that nature. So there's different ways of optimizing. So let me see. I'm not sure exactly what data points we share. Let me ping my team on the on the TPS.
Yeah, and so Dan, we'll get back to you on this question after the webinar. Maybe we can send you an offline response. Maybe we'll send it to all of the participants on the webinar as well.
Yep, I know that it's in the hundreds to thousands right now for QLDB. Frankly, the team doesn't want us to share numbers because they're doing a ton of optimizations. So we don't want to kind of share any older data, but if we're talking about comparison to blockchain networks, yeah, it's clearly far more performant and robust as far as that goes. Again, going back to ACID and OCC concurrency models, I think from the QLDB layer, that's how the transactions are persisted on the ledger. So it does support optimistic concurrency and atomic isolation of transactions. So it either fails or succeeds. You can have conflicts, let's say. So if two of them come in at the same time, so the earliest timestamp would be persisted. So pretty similar to a database from that perspective. Obviously, the application logic will be probably more important here to kind of weigh different routes, and which is why we have demo folks here to tell us a little bit more on how to build transaction workflows where you might have those conflicts if you do have infinite scale.
Yeah. Okay. Perfect. So Levi, I think you can carry on, I think, and in a couple of minutes we'll hand over to Duncan as well.
Yep, will do. I'm nearly done here. So the next part of this workflow here is to start a purchase order under that license. So now I have a contractual relationship number 11.1, which ties all of these groups together. And what I'm going to do is now put in a fulfillment request. So I'll put in the referring contractual relationship. The subcontract, let's subcontract this thing out to subcontractor 1. The order details is, let's say, let's just give this an ID. The product is going to be, you can imagine like this is a car manufacturer going out to an engine manufacturer and say, I want, you know, a bunch of engines. I want 1,000 engines at 5,000 a piece. So I'll go ahead and submit that. I'm logging in as now subcontractor 1, who's presumably a manufacturer of engines. I can say go ahead and I'll accept this request here. So now there's an active order that as subcontractor 1 I'm working on, and I can subcontract bits of this out to the various subcontractors. So I'm gonna send subcontractor 2, let's say the cylinders, and I want 1,000 of these, and I'm gonna pay you 200 each, and so forth. So as subcontractor 2, oops, that's the auditor. As subcontractor 2, I'll say there's a fulfillment request for me for a bunch of cylinders with respect to our relationship specified here. That's the contract. And I'll say I'll accept it. Once the order is approved here, I can request a loan on it. So now I can go directly to the bank and say, bank, please go ahead and give me $1 million to get started here. And hopefully that's the correct number of zeros. I'll submit. And now there is a loan request. There's a loan request out here. And as the bank, I can log in and approve that loan. Approve the loan that the subcontractor gave me. And they asked for $1 million, but I'm gonna only approve 800,000. And there we go. So now we sort of secured financing. So that's the end of the workflow. It's a very simple workflow that ties together a manufacturer, a number of subcontractors together, and it allows those subcontractors to ask for loans from a financier. So you can see how that this is a multi-party application. The trust barriers for all of this, which is important for QLDB, could be such that the bank is running this this particular application, or it could be one of the manufacturers running the application as a centralized service. Even though it's a centralized service, Daml and QLDB ensures that everybody's privacy is still protected at the application layer. So as any of the subcontractors, you're 100% certain that none of the other subcontractors sees your data. And this is thanks to Daml. QLDB itself ensures the integrity of the whole thing, so that any of the contractors who log on know that they are working with exactly the same golden source of data that everybody else on the network is operating on. So there isn't a reconciliation issue, and you don't have to worry that you're accidentally double spending or exercising a contract that has already been archived. Behind this, like I said at the start, to describe that entire workflow that we saw, it's about 228 lines of Daml code, which has nothing to do with the underlying infrastructure. So you're not having to worry about QLDB. You let QLDB do what it's good at. You're only describing what each of the different steps in the workflow entail in terms of rights and obligations and disclosures to the different participants within the network. You let the infrastructure take care of things like authentication and visibility and things like that. In addition, this will serve an API for you if you're a participant on the network, where you're able to exercise the choices that have been granted to you by these smart contracts. So for instance, on a loan request that we see here, before the bank, only the bank is able to approve the loan or reject the loan. Nobody else in the system is able to even see the request to you.
Yeah, perfect.
Okay. I think I'm done with that.
Yeah, thanks, Levi. So before I hand over to Duncan, just a couple of things that came up. One, of course, there's a question from Manjusha in the chat in the Q&A. I think so. Her question is, do all the participants need to deploy a node for this application to function? You know, ideally, what we've shown you is an application that obviously can run decentralized, but in cases that Levi mentioned, you know, for the reasons that Levi mentioned, not all subcontractors in the network may have the wherewithal to host their own node, manage the infrastructure, you know, create their own IT, you know, support processes and all that. And that's the reason why we think this could be a nice, you know, use case to deploy on a centralized system such as a QLDB, Daml on QLDB, which allows them the same privacy guarantees, but also does not need, you know, any one of these independent contractors for the need to host nodes and manage the infrastructure and all of that stuff. And any one of the trusted parties in the network, like a bank or a manufacturer, may be able to host the network and allow everybody else to participate.
Just my experience there, like most of the sort of enterprise grade, quote unquote, blockchain projects that I've ever encountered, something like 95 to 99% of them, even if it was ostensibly a completely distributed system, most of the time the wallets and the keys were managed by a single trusted entity.
Yeah.
So
like a consortium model.
Yeah. So basically, QLDB or a centralized model reflects that completely faithfully.
Yeah. And Levi, just one quick question on GDPR compliance. Do you have a quick comment on that?
Right. So on particularly the right to forget, it might be sort of contrary to the goals of blockchains and things like that. But the nice thing is that only in a Damlized ledger, only the active state of the ledger is available for querying. In other words, if a particular contract that contains forgettable data is on the ledger, but then gets archived, that contract is never again available to anybody else on the network. At the persistence layer, that answer might differ. So different implementations of a Daml ledger will implement the sort of the right to forget a little bit differently.
Okay, great. Yeah. So at this point, I'd like to welcome Duncan. So Levi, if you can stop sharing and we'll let Duncan share his screen. And Duncan is going to talk about the Sextant platform, which also enables Daml on QLDB, among other ledgers.
Thank you. Thank you very much. Right, here we go. So one picture, and then I'll get straight into it. So Sextant is a blockchain and smart contract infrastructure management platform. So it really takes care of all of the issues around deploying and managing that kind of infrastructure. And so in this schematic, which obviously focuses on what we're doing with AWS and DA, Sextant for Daml itself runs on Amazon EKS, an Elastic Kubernetes service. And then it takes care of all the issues around deploying either Hyperledger followed by the Daml runtime, or what I'm going to show today, the Daml runtime running on the Amazon Quantum Ledger database. And of course, we also have Aurora. So in the time available, I'm not going to get into too much detail about how it works, but instead let me just, and hopefully you can see my screen, I should have asked. So everything I'm going to show you here, you can actually go and play with yourselves. The way that you would do that is by subscribing to a version of Sextant for Daml that is actually available on the AWS marketplace. And essentially, the best way of thinking about us is we're really very, very big on what Digitalasset call their Daml on X strategy. And this is a strategy driven by the customer use case. So this is not about politics or about opinions. It's about what is the best underlying Daml ledger implementation for you. And so there's a little decision tree here that just takes you through that. And of course, besides ourselves, there are other digital asset partners that are also offering support for both private or permission blockchain, as well as other solutions. But I'm focusing on the three that we currently support. We actually announced support for Daml and Hyperledger Besu, which we'll share details of after this as a follow-up, but that's not currently available in the AWS marketplace. So yeah, the marketplace.
I'll send information on that to everyone in my follow-up email after the webinar.
Excellent, thank you very much. So of course, in the interest of time, I've already subscribed to Sextant for Daml in this case. I've installed it, all the instructions for doing that, how to install it are dealt with here. Again, not really the time and place to go into that, but it is very straightforward. I'm a CEO. If I can do it, you can do it. Okay, so as we say in my company, I'm the idiot that makes our products idiot-proof. Although the engineers are quick to point out, they make them idiot-proof. I discover what's wrong with them. Anyway, that's by the by. So let me look at, and this is a cookery program. So I have made I have deployed a Daml on QLDB environment earlier, but let me just show you what I did. So essentially, you have access through the Sextant user interface. This is a software product, by the way, not as a service. It may look like as a service, but we provide it as a product so that people can take it and deploy it how they wish, whether they want to be the network operator or they want to hand out Sextant and give individual members of a consortium control over their nodes if it's a distributed ledger or whatever. We can, in fact, run it as a service for people if they want that. But my point here is, again, we're trying to be agnostic and really understand the use case, the business case. So typically what you will do is you will add a deployment, and here are the choices currently available, as I was saying. So Daml on Sawtooth, Daml on Aurora, and the one we're going to focus on today, Daml on QLDB. So all of these, the key point here from a Daml user or developer point of view is the back end underlying Daml ledger implementation should behave like everything from your sandbox to Project Daml to any of the ledger implementations. So your code, your contract should be portable across any of those. And so we have to support the standard entry point, which is currently a gRPC endpoint. So rather than deploy that here and now, in fact, I could set a deployment going, but rather than do that, I'll come back to the existing deployments. Let's have a look at this one. So this is looking at really the sort of internals. So we've got the important thing from your point of view, if you're interacting with us, is there is a Daml RPC load balancer. So this is just a standard load balancer that lets you talk to the entry point. So if you're familiar with working with Daml and the Daml command line, it's exactly the same here. So to prove there is no skullduggery, if I look at that cluster from the standard command line, you can see all of the componentry here, which is rendered in this. But what's interesting in terms of following this is we're now gonna spy on what's happening inside of our ledger implementation. So at the moment there's just heartbeats and whatnot, but it gets interesting when we flip to 1 second. We flip to and I rather skipped over this. We are not running locally. We're not running a sandbox. There is a host, an IP address exposed as an external IP by Amazon through this load balancer, and it's the standard port 39,000. So I can connect to that, but that's not very interesting because nothing is actually in there at the moment. I can show you that nothing is there because one of the nice things we can do is we can actually just inspect the ledger and say, what is there? And the short answer is, there is nothing there at the moment, okay? So let's deploy something. And again, I don't want you to do anything untoward in terms of anything that you're not used to doing. So you'll notice that I'm actually in the structured trade finance GitHub repo. So I'm not going to actually connect to that using the navigator yet. I'm actually going to just hit deploy. Okay, so I'm going to hit deploy on the left. This is standard. This is going to just pick up the instructions from the GitHub, and instead of deploying it to Sandbox or to Daml, it's going to deploy it to QLDB. And on the right, if all goes well, we should start to see some activity. So you can see we're deploying, but we're deploying. So you're seeing the readout from the Daml deploy, and then you're seeing the internal, if you like, log of what's actually happening. So this is us basically, and it's succeeded. Now we have to just wait a minute for this guy to catch up. But if we go here, you can see the parties have been loaded. So this is exactly the same code and demo that was being demonstrated by Levy a few minutes ago. And there are all the, if you like, the internal artifacts that make up that set of DA contracts and the DA application. And again, finally, because I'm conscious I've only got a couple minutes left, let's again look at this from the point of view of the navigator. And trust me, I'm not going to run through the whole demo again, but I just want you to see that that again, Ledger Navigator. We should be able to hop onto this. Famous last words, looking good. So now if we go to there, now I am connected through to my local machine. So Daml host, that is basically, as you can see, all of this. So that is talking to the QLDB backed Daml ledger in the cloud. And now finally, I will just hop onto here. And if I open up a new window, and you will see something looks remarkably similar. Now, so to summarize, we've done all the heavy lifting. We've deployed running Daml on QLDB implementation connected through to AWS. We have actually, in the background, we've actually created a ledger, which is again done on, I didn't go into the details of the deployment, but that was the name I gave the ledger. We use S3 at the moment. If you look at this guy at the bottom, we use this as a blob store. And this is essentially because some of the packages in Daml are significantly large. So we store these blobs using the hash of content as the ID. So this is an S3 feature. And then we store that hash on chain. So if anybody tries to corrupt this, first of all, we won't be able to see the data in S3, and if we were able to see it, we would know straight away that it was that it had been tampered with. So we're actually using a combination here of QLDB and S3 in the background. So apologies, I've galloped through that, but I hope you get the general idea that you didn't have to touch any of the back end stuff, and literally all you do is interact with this in the same way you would with any of the Daml ledgers. And that's what Dam1X is really all about. It's ensuring that you pick the right implementation of the ledger for your particular use case. And obviously today we're focusing on the Amazon QLDB or Quantum Ledger Database implementation, but we have Hyperledger Besu coming shortly to the AWS Marketplace Edition and also Amazon Aurora. So you want to know more, Manish will have obviously send out the instructions, but that's all I have time for.
Yeah, and Duncan, thank you so much. I mean, that was really good. Just one question that came up, which I wanted to address. How many Kubernetes pods do I need to run Sextant with QLDB?
So it's really, I think what that question is getting at is how big or small does my Kubernetes cluster have to be? In the case of the quantum ledger database, you could see the footprint is very small. There's Sextant itself, and then there's just the Daml integration. In the case of Daml and Sawtooth, the number of pods corresponds to the number of validators or nodes in the network, broadly speaking, and you tie an individual validator to a worker node. So the minimum you would need in terms of the size of a Kubernetes cluster, if you're running something like Hyperledger, Daml and Hyperledger Sawtooth, is 4, preferably more, but 4 is okay for PBFT, which is the standard consensus we use. Same with Besu, which uses IBFT. But in the case of the integration with Amazon QLDB, as Lana said at the very beginning, it's a serverless service. And so, a lot of that heavy lifting in terms of the resilience, the reliability, and scalability, and so on, is handled by Amazon itself. And so we are back to that picture I showed you at the very beginning. We're leveraging all of that scalability across both Amazon Aurora and Amazon QLDB. And in fact, Kevin, my CTO and co-founder, was talking to me about this just beforehand and said, we're probably thinking, but we might actually, instead of using S3, actually use Amazon Aurora to as our sort of blob store, quote unquote.
Perfect. Thank you so much, Duncan. So yeah, that brings us to the end of the webinar. There are, the luxury of having a virtual meetup is that I'll be able to send you a recording of this webinar latest by tomorrow. And then if you have any questions, feel free to get in touch with me and any of the panelists, of course. And then we can help you sort through your experimentations with Daml on QLDB and Daml on any other ledger, of course. So thank you so much. Any final words, Lena?
I think on our end, no. Thank you so much, everyone, for joining. I know it's kind of a weird time, but very excited to keep building really cool products and get more feedback from you on what's working, what not. Please take it for a spin, and let us know if you have any questions.
Perfect. So thank you, everyone. Stay safe, and expect an email from me by tomorrow with the recording and some other useful links that we discussed on the call. Thank you.
Thanks, everybody.
Thanks, everyone.